Welcome to this channel. In this video, we will derive the Euler-Lagrange equation by principle of least action, which is d mu partial L over partial d mu phi minus partial L over partial phi is equal to 0. Here, L is Lagrange density, phi is Lorentz scalar, and d mu phi is Lorentz vector, and mu is equal to 0, 1, 2 and 3. And Lagrangian density is the function of phi and d mu phi. This is equation number 1. And the least action is I is equal to integral L dt, and here L is Lagrangian. Lagrangian is related to Lagrangian density as L is equal to integral d cube x Lagrangian density. So least action become I is equal to integral dt integral d cube x Lagrangian density, and in 4 vector integral dt integral d cube x is equal to integral d fourth power of x. So least action is equal to integral d raised to power 4x Lagrangian density. This is equation number 2. This is equal to action is equal to integral d fourth power of x Lagrangian density, which is function of phi and d mu phi. For least action, delta I is equal to 0. So question 3 becomes delta I is equal to integral d fourth of x delta Lagrangian density, which is function of phi and d mu phi is equal to 0. So this becomes integral d fourth power of x partial L over partial phi delta phi plus partial L over partial d mu phi delta d mu phi is equal to 0. Since delta d mu phi is equal to d mu delta phi, so this becomes integral d fourth of x partial L over partial phi delta phi plus partial L over partial mu phi d mu delta phi is equal to 0. This can also be written as integral d fourth of x partial L over partial phi delta phi plus integral d fourth of x partial L over partial d mu phi d mu delta phi is equal to 0. This is equation number 4. Now integrate second term by parts. So since integration by part is integral u v prime dx is equal to, if we consider v prime is the first function and u is the second function, so this become v u minus integral v u derivative dx. So in second term, if we consider this is first function and this is second function, so this become integral d fourth of x partial L over partial phi delta phi plus partial L over partial d mu phi delta phi from x is equal to a naught to x is equal to a1 minus integral d fourth of x d mu partial L over partial d mu phi delta phi. Since delta phi of a naught is equal to delta phi of a1 is equal to 0, so this term is equal to 0. So remaining become delta I is equal to integral d fourth of x delta partial L over partial phi delta phi minus integral d fourth of x d mu partial L over partial d mu phi delta phi is equal to 0. So this can also be written as integral d fourth of x partial L over partial phi minus d mu partial L over partial d mu phi delta phi is equal to 0. Since delta phi is arbitrary, so this term become partial L over partial phi minus d mu partial L over partial d mu phi is equal to 0. This is Euler-Lagrange equation.